So we have here an example of an application that performs remote sensing. One of these applications is what we call as the ISODATA procedure. And what is ISODATA? When you say ISODATA, that just simply means or stands as iterative self-organizing data analysis technique. It is a supervised clustering algorithm used in remote sensing and image processing for classification of digital images. So ISODATA works by analyzing the pixels values of an image and grouping similar pixels into clusters. So it starts by randomly selecting a set of pixels as initial cluster centers and then iteratively refines the clusters by reassigning pixels to clusters excuse me, and recalculating the clusters center based on the new assignment. The algorithm then checks whether the number of clusters is optimal, and if not, it is either merge or split cluster to obtain the desired number of clusters. So ISODATA has several parameters that can be adjusted to control the clustering process, such as the maximum number of iterations, the minimum and maximum number of clusters, and the minimum distance between cluster centers. The algorithm can be set to automatically determine the number of clusters based on statistical measures such as within cluster variance and between cluster variants. So ISODATA is widely used in image classification and segmentation, particularly in the field of remote sensing for analyzing satellite and aerial imagery. It has the advantage of being able to handle large data sets and produce accurate and consistent results with minimal user input. So let us see here what is or what are then the procedures involving ISO data. So here in our presentation, it has an arbitrary cluster means as established. The image is classified using a minimum distance classifier. And then there is a new mean for each cluster, which is calculated. The image is classified again using the new cluster means. Another new mean for each cluster is calculated, and lastly is the image is classified again. So as you can see in the procedure, there is a repetitive as based on the definition of the ISODATA or how the algorithm works. There is a repetitive process of analyzing or say classifying the data and of selecting the pixels of the data until you will derive the correct image classifications or prediction. In continuation to the ISODATA procedure, so we have after iteration, the algorithm calculates the percentage of pixels that remained in the same cluster between iterations. When this percentage exceeds exceeds T as the convergence threshold, the program stops, or if the convergence threshold is never met, the program will continue for M iteration and then stop. So we have the point is a special case of a minimum distance clustering for ISODATA, which is also another extension of the performance of the ISODATA application. So in this special case of minimum distance clustering, there you have the iterative self-organizing data analysis technique. So parameters you must enter would include now N as the maximum number of clusters that you want, T as a convergence threshold, and M, the maximum number of iterations to be performed. These are now the ISODATA clusters that is formed. So ISODATA initial arbitrary up to the last phase of or of the band 4 phases of clustering the data. So we have learned as to how the ISODATA works. So let us explore now what are the pros and the cons of the ISODATA application. One is not biased to the top pixels in the image, sequential clustering can be. Non-parametric data does not need to be normally distributed. Then it is also very successful at finding the true clusters within the data if enough iterations are allowed. And then cluster signatures saved from ISODATA are easily incorporated and manipulated along with supervised and spectral signatures. So what is the final thoughts of classifications or classification? So classifications are never complete. They end with time and money run out. So classification is iterative. So repetitively, there you have now process of repeating the process over and over. It's tough to get it right from the first iterations. So with this, you will be needing a lot of resources, both input and output. And then consider a hybrid classification, part supervised, part unsupervised. And then manual classification and or editing is not cheating. So we have here an example of a classification of a Landsat, digital color na infrared. Another classification captured from Landsat TM, which is in digital color infrared again, and spatial resolution of 20 meters. And Landsat MSS, another digital color infrared. So another 57 meters captured. This is the corona or the panchromatic film captured of 3 meters data. The characteristic or result, an example of classifications. So the transitions and the different iterations results conducted when remote sensing is applied. Another scene classification of an object na car as visually transformed into classifications depending on the object captured or analyzed. And then there you have now the different classification that can be captured on an object depending on the object. Like for here, we have car, pavement, or tree, and there is a transitions of captured data of an object subject.